G'day guys, how's it going? So in this video, we're going to look at something called compound assignment expressions. And it sounds like a lot in terms of what it means, but it's pretty straightforward. So essentially, let's say we have a variable, say x, right? So sorry, I'm just going to select and goes let x equal 0. Cool. Now, obviously, once we do that, we've always said that later on, if we want to update that to say 10 or something, then all of a sudden we can't do it because we need to make it mutable, right? So we come up here, we set it to mute, and then we're able to assign the value, right? But assignment was only one thing that you could do. You could also do something like take the current value of x and maybe add 10 to it, right? So if we were to do this and then we're able to print out accordingly, x is like this, and save and run this, well, obviously what we're going to get is the value of x is 10, okay? Now, if I want to continuously update this every single time, so say now again, I go x equals x plus 20, and then x equals x plus 4, and x equals, let's say now, x plus, I don't know, 3, right? It's starting to get a little bit messy, right? Because we have to continuously repeat the same thing over and over and over again, right? So we still need the four statements, but we could shorten this a bit, right? And the way that we shorten it is what this compound assignment expression is. So another way of rewriting the same thing we have here, right? Say this first line is to go x plus equals 10, right? And that's the equivalent of x equals x plus 10. So if I come down to the next line, I do the same thing here. I get rid of the x plus. I think you get the picture, right? So we have plus and plus equals 3. And if we run this, we're going to get something like 10, 30, 34, 37. And as you can see, it's 37, right? So this is a shorthand notation that we can use to increment, essentially, because this plus is increment the current value by 10, increment the current value by 20, increment the current value by 4. And keep in mind, for each line, it takes the previous one. So it's x is 0 here, so that becomes 10. Then x is stored as 10 here. Then you're plussing 20, so this is now 30. Then it's 30 plus 4 is 34, and then 34 plus 3 is 37, and that's why we get 37, right? And that's that compounding effect. Now, addition is just one version. There are other ones as well. So let's just refresh all this, and we'll go x plus equals 1, just to keep the numbers down a bit. And then let's go plus equals 6 again. What we could also do is now go, okay, now I want to subtract 3. So you can use subtract equals. You can use multiplication. So we could go something like x times itself. X is equal to x times, in this case, 10. We can do division, right? And this, in this case, would be integer division, just so you know. So, but we'll make it equal to 2, so it's even. And then ultimately, we could, in theory, get the remainder, right? We could get the remainder from what the value of x is and put that inside of x, right? So what we've got here, if we go through it slowly, is x is equal to 0 at the start. It's mutable, so we can change it. We then add 1. We then add 6. That's 7. We then minus 3. That's 4. Then we times it by 10. That's 40. Then we divide by 2. That is 20. And then we try to get the remainder if we were to divide by 3. All right. So that's what? It's 18 plus 2 remainder. So essentially, what should come out at the bottom here is 2. All right. So let's just save and quickly check that. And there it is. X is 2. Cool. So this is that compounding effect, and you will use this from time to time, especially when we talk about loops very shortly. But yes, I just wanted to quickly show you that because it's something that can be quite handy in Rust. But that's it for this video, and I'll see you all in the next one.